I told you whenever we started this chapter that today was really important. I said that to you when you walked in on Monday. I said, look, there's one day this semester that you can't miss. It's this Friday. And then all the FESCON kids said, uh-oh. That's why Brazuco's so wonderfully helping us out to take this. Oh, I forgot to tell you that story. You can take this too, I don't care. All right? So, last hour. I told you what we're supposed to have at the table, did I?
Yeah, Joe Biondo.
Biondo was supposed to do it, right? So we're in here last hour, right? And I did the same thing. I went over the stuff with the homework, and I told him, don't hit play until I start, right? So I went over everything in the homework, and I started with the unit circle, and I didn't tell him to go. I figured he would, right? So I'm going through everything on the unit circle. I get done at the end of it, I was like, Biondo, you can stop the video. He goes, stop. I didn't even start it yet. We're like 10 minutes from the bell at this point in time. I mean, the class is over with. Good work, dude. That's why Brazuco's here to help us out at this point in time. Don't make fun of Biondo, please. He's already really pissed at me over this one, okay? And he's my age, he makes all your copies, so don't make him too angry. I just thought it was funny. I thought you might want to know that. So here's the deal. When you walked in here, I told you, I tried to play wizard stuff on you. I was like, hey, guess what? I know that the sine of 30 degrees is 1/2. Ha, you're going to need to know that. I did this with a bunch of stuff, right? Acting like I was all smart. But I told you, you would be able to do this today. That's what today does. After today, you're going to have to be able to tell me the sine, cosine, tangent, secant, cosecant, and cotangent, all 6 trig functions of any angle, any one of them, if it's an increment of 30, 45, 60, or 90 degrees. Any one of them, you have to be able to provide that to me. Above 360, below, I don't care. A lot of people look at that and think that's a daunting task. That's impossible. It's really not. It turns out there's a lot of ways to do this. I'll show you 2 of them, and I will lean heavily on one of them that I like. You can do either one. I don't care whatsoever at all. Carmen and I agree on most things. We do. We disagree on one specific thing that I'm aware of, and it's the best way to figure out these things, to figure out all the different trig functions. She will swear for days on special triangles. Swear on special triangles. Fine. I don't care. I don't care. It's fine with me. I have found in the past a different way of defining this, maybe a little bit easier, okay? It's up to you. I really don't care. But I'm going to provide you with both options here today. I'm going to tell you, you need to have this skill. You need to have that skill with any trig function, period, of a 30, 45, 60, or 90, you have to be able to find it every single time, okay? So as a result of that, you figure out your method today that works for you. I'm diagramming out the 45, 45, 90 triangle, the special triangle there, as well as the 30, 60, 90 special triangle on the board. The other thing I'm going to do, I'm going to diagram out the unit circle over here. The unit circle is my mnemonic device to help remember. Up to you. Don't care. Now, what the unit circle is, here, let me draw it first, and I'll tell you what it is, because it's really important. 1, 2, 3, 4, 5. All right. I'm going to try to draw. It normally doesn't go well, you know that. Now step back, how'd I do?
It's like a kite liner.
It's like an alien head.
It didn't matter what I did, you'd never like it.
No, that's just like.
But that triangle up there, nice.
Yeah, the first
one
one.
I was like,
Yeah, it was good?
No mistakes.
It was
Just
good?
fix the like left bottom side.
Huh?
Yeah.
We can't do this forever, all
I
right?
know, I'm just saying, that's the first one.
Flow, flow, flow.
No.
Okay, always go out more than you think it should be.
Oh, okay.
No, that's like really a lot better. It really is. No. Oh,
One more!
That was good.
We're not doing this all day.
Okay, there you go.
Okay. That's the best one.
I'm proud of me too.
Here's all the other ones.
All right, we're gonna go now. We're gonna go now, okay? So here's the deal. This part's important, this part's important, this part's important. This is the unit circle. What it means by the unit circle is the radius is 1. 1, 1. The radius is always 1. Now, the radius being 1 should tell you where this point is right here. Don't count 1, 2, 3, 4, 5, 6. This is 1 going on right here. Why did I not make it 1? Because you can see it. I made it 1. I'm blowing it up just a little bit. If this is 1 right here, what is the coordinate on the edge of that circle? Right there.
1, 0.
1, 0. Absolutely right. It turns out I'm going to show you a way to be able to find out the 30 degree, the 45 degree, and the 60 degree, and the 90 degree point on the unit circle. And it turns out those points on the unit circle can also be used to figure out these trig values. But I'm not just going to tell you the points on the unit circle. I'll use these special triangles to define that so that you can see where it comes from is the idea. Here's the beautiful part of it, guys, if you're listening. If you know this and one little trick, you can do all of it. Over and over again forever. Because it turns out this quadrant does actually have a pattern that rolls through the entire process involving reference angles. Let's come back here. With regard to your special triangles, when you did them in geometry, with the 30, 60, 90 triangle, this was 2x, this was x, this was square root of 3x for the ratios that were applied between the sides. With regards to the 45, 45, and I get it, that's bottom side waves just a little bit, but that's all right. With regards to the 45, 45, these two sides were the same length, and the third length, or the hypotenuse was square root of 2 times that. As I said, two ways to do it, two ways to define it. Doing it with regards to these guys, okay, is pretty simple. And I showed you a little piece of this, a little piece. I'll do one of them to show it to you. Let's say, for example, we wanted to know, who cares, the tangent of 30 degrees. Well, if you know this is the special triangle, you can reference 30 degrees. There it is. No, tangent is a measure of opposite over adjacent. Take the opposite side, x, divided by the adjacent side, square root of 3x. We talked about this yesterday. And cancels the x's. Goes to 1 over 3, square root of 3 is what happens right there. You can do that. That works every time. If you want to draw the triangles every single time. But in my experience in the past, number one, you don't remember them from geometry. Okay? You know they're there, but you don't remember the side lengths on them. Okay? And number two, I never saw any really easy way to remember that. The way I'm going to show you, I think, is a better mnemonic device. Up to you. I don't care. I really don't. Now, for me to define this unit circle, these coordinates on this unit circle, there's a little grid you need to know about. I would write this on your paper in the top right-hand corner. On the unit circle, that's on the unit circle right there. Cosine is x. I'm giving you that information. Sine is y. You need to know that, okay? Everything else we can define in terms of that. Everything else. But you need to know cosine's x and sine's y to make it work. Now, to figure out tangent, I'm going to use this lovely little theorem that you just created right there. Because if sine's y and cosine's x, and we know tangent is a measure of sine over cosine, well, that means tangent is a measure of sine was y, cosine's x, it's y over x, is what that piece is. Again, you're buying it a little bit, but you don't see where I'm going. Don't worry, you'll get there, I promise. That's your tangent value. And it turns out all the other ones can be defined using the same thing. Because the reciprocal of cosine was secant. Well, if cosine's x, like x over 1, secant, hello, is
1 over x.
Yep. Should be pretty easy with the other ones. If sine's y, cosecant its reciprocal is, you're writing, I get it.
1 over 1.
It's 1 over y. Flips it. And I'm not going to say it out loud, but why don't you go ahead and write in the reciprocal, or the reciprocal function of tangent, the cotangent right there on your paper. What'd you get, guys? What was cotangent on the unit circle? X over y. It's the root of shame. It's easy. So, and I always found that pretty easy. I did. I knew that top one cosine was x. I knew that bottom one cosine was y. I could find everything else based upon it. If you have that, you can make that work and understand your reciprocal pieces. Okay. Other than that, the other things that I did in order to make it work, we're going to take this unit circle and we're going to inscribe these triangles inside this unit circle and use that to help define things. What I'm going to provide you with, if you're listening, is coordinates around the unit circle that are going to help you, using this lovely little chart, find any sine, cosine, tangent, secant, cosecant, or cotangent of any angle period. This is the way that works. They must be in increments of 30, 45, 60, and 90. I will tell you, I will not ask you cosine integrals of 30, 45, 60, and 90, okay? That's what you need for right now, but you need that to make it work. So we're gonna start here with the 30, we're gonna start here, my fault. This is 0 degrees. You agree? Hello?
Yeah.
Okay, so no calculators, right? Don't touch it. Cosine's x, right? What is the cosine of 0 degrees? What is the x value right there at that coordinate?
1.
1's correct. Put in cosine of 0 on your calculator right now. It was 1. Simple, right? And I'm starting here because it's obvious, okay? Now, at that point at the unit circle is 1, 0, right? Cosine's x, which is 1. Don't touch your calculator. Sine's y, right? What's the sine of 0 degrees going to be?
0.
Hello?
0.
0. Yeah, it's 0. Absolutely right. Define on that. Pretty simple, because it's the y coordinate right there. And we can do all of them, every single one of them. Try tangent. Tangent is a measure of y over x. You don't need the calculator. Hello, what's y over x?
0.
0. Yeah, 0. Check it out. Tangent is 0 or 0 is 0. It works every time. What I'm showing here is what I'm showing you here is that we can define every single one of the trig functions at any given actual degree measurement based upon the coordinate on the unit circle. Because based upon the coordinate on the unit circle, we can find any single one of these things right here. And that's the idea we're incorporating or building as we go through this process right here. Okay?
Does a cotangent of 0 not exist?
That's a great question. I was going to ask that just a second ago, but let's let them figure it out. Check out cotangent of 0. Cotangent's x over y, right? What is 1 over 0, people?
Error.
Call undefined, as we call it. No, it does not exist at that point in time. It's an undefined value happening right there for that reason. Very good. Oh, what's happening? Everybody okay? Good? Okay. I'm going to do this every time. I'm going to get you the coordinate right there, and then I'm going to be like, what's sine? What's tangent? What's cotangent? What's secant? It's all based upon this right up here. So if you have this coordinate on the unit circle and this lovely chart going on right here, you can define everything, is the idea. And I think there's a lovely little mnemonic device that's going to be helpful in here for you when we get there, okay? That's why I choose it, but I still don't care. If you want to use special triangles every time, I still don't care. I never will. Because I'll use special triangles to define this. So we're going to go to 30 degrees at this point in time. As I go to 30 degrees, you don't have to do this, I'm going to. I'm going to inscribe a 30-degree or a triangle inside here, a right triangle. In fact, I'm going to try to draw a right triangle. Now, in this right triangle, clearly this is the right angle happening right here. If this is a 30-degree angle, that means this is the 30 degrees, and that's the 60 degrees. Model it after what you have over here. There's a little trick that happens with the unit circle. What did I say the radius of the unit circle was always?
1.
It's 1, which means this right here is 1. Well, if that's 1 right there, 1 corresponds with the side over here that is the hypotenuse. Oops, the hypotenuse, which is 2x going on right there. Therefore, if 1 corresponds with the side that is the hypotenuse, which is 2x, solve for x here, people. When we divide by 2,
Half.
x is a half. How does that help you in this situation? Because that says x, and if that's 1 right here, that's a half. And once again, as we look, we found out the x value was a half. If x is a half, square root of 3 times a half, I call that like square root of 3 over 1 times 1 over 2. We call that square root of 3 over 2. As a result of that, it defines the sides. What does that mean? That means here in this normal triangle, it was 2x, x, and square root of 3x. But if I make this side 1, the equivalent ratios would be 1/2 on the y and square root of 3 over 2 on the x. That would be the base, that would be the side, this would be 1 right here. Do you get what I set up and how I rolled around that? Are there any questions? I'll do a lot of this, okay? Are you okay with what's happening right here?
Yes.
I saw a lot of people fade right there. Come back to me, okay? Why is this critically important to you? Because at this point right here, this is the x coordinate, this is the y coordinate right here. Therefore, the x coordinate at 30 degrees is square root of 3 over 2. The y coordinate at 30 degrees is 1/2. And there's that point defined. And now we play games. Alright? Don't touch the calculator. What is
Can you put it in decimal form?
no? And I'll tell you why. I will not allow you to put it in decimal form because your calculator, I need you to be able to do this without a calculator for a reason. The calculator gives it to you decimally. I will never accept these as decimals, ever. Okay? It's always got to be in square root format. Alright, so you should chart. Here we go. What's cosine of 30?
Square root of 3 over 2.
Cosine is x. X here at 30 is square root of 3 over 2. Cosine is square root of 3 over 2. Your calculator will not tell you that at all. It'll simply give you the decimal equivalency, okay? But that's what it is. It's really simple and it rolls through. And we're going to get through how do I remember these pieces. We'll get there, okay? I need you to know how to work with them to start. Let's try sine. What do you think sine, wait for it, Riley, give him a chance. Sine of 30 degrees is, go ahead now you can tell me. It's a half. It's absolutely half. Riley's on this. All right, that was really simple. Okay, it's not hard. And you can do everything, everything. Let's try a weird one. Let's try cosecant. What do you think cosecant of 30 degrees is? I'll give you just a second on that. Go ahead. 2. It's absolutely 2. Because it's 1 over y. Y here is a half. And 1 divided by a half is 2. I'm getting a little messy at the top. I'll erase that in a minute. I'm just showing you the pieces to it. And every time I bounce around, I'm going to show you these little things, okay? So beyond right now, I want you to be able to find it and then plug it into the calculator to verify it, okay? Real quick, plug in sine of 30 to make sure I'm not lying to you, but it's a half. Right there at that point.
Is tangent of 90 also
Because it's flipping that essentially 1 to 0, 1 at the top. Yeah. That's why it gives you the undefined of the error. When you plug it in, we'll talk about it. That's me defining 30 degrees, and I'll roll around from there. Questions right here on the 30-degree one. Every time I'm going to get you the coordinate, we're going to play a couple of games so that you buy it, and then we're going to keep rolling because we got to define the entire unit circle. Are you okay on 30 degrees? You have to talk to me, yes or no?
Yeah.
And please understand, this is not an option for you to be like, I don't get it today, but that's all right. No, it's not. It is not okay if you don't get it today. You need to get it today, okay? So stop me if you need to at any point in time. Yeah.
What about tangent of 30?
All right, great question. What about tangent of 30 degrees? What about it? All right. Well, Dawson, off the top of my head, I'm not really sure. Here's what I know. I know this coordinate is square root of 3 over 2, 1/2, and I know tangent is y over x. So I'm going to take the y coordinate divided by the x coordinate. You are responsible for the algebra from here. What will happen is if you multiply times the reciprocal, is what's going to happen. What's left is 1 over square root of 3. That's what happens, and I'll allow you to leave it like that. That's what's happening. But that's exactly what goes on when we go through this. That's what should go through your head. You need to understand the mapping to it and how to apply it on every single term. Good question. Everybody good?
Yeah.
Go to 45. So as we go to 45, I'm going to erase this across the top. Make sure we see each piece. As we go to 45, I'm no longer referencing this triangle. Now I'm referencing this triangle for the bottom. So as we look to the bottom triangle, looking to the bottom triangle, I'm going to play the same game. You'll see these triangles disappear inside every time so that you can see what's happening. So that one's gone now. Now we're talking about the 45. With the 45, let's get it perfect. It goes right there on this. It's close enough. 45 degrees. Drop it. Drop it. This would be a 45-degree angle. That's your right angle. That's the remaining number of degrees, which is still 45 right there. Based upon this triangle. Again, what did I do whenever I started with the 30? I said this is the unit circle. Since this is the unit circle, this radius must be 1. And since this radius must be 1, I'll use that 1 ratio over there to find me the other sides of it. The hypotenuse must be 1. When this works, you always want to solve for the y value when that happens. So you divide by square root of 2. Turns out, let's get rid of it. The y right there is 1 over square root of 2. Normally, I would not care here. I wouldn't, but I'm going to rationalize this to make your life easier. It turns out the little mnemonic device that I'm going to break out just a little bit is a lot easier if this is rationalized. The way we rationalize is we multiply times the square root of the bottom. If you multiply times square root of 2 over square root of 2, understand why it's legal. That's 1. I multiplied times 1, not changing the value, just the form. Tops go to 1 times square root of 2 is square root of 2. Bottoms go to, hey, you, what's square root of 2 times square root of 2?
2.
It's 2. I'm going to make that y squared 2 over 2. This is absolutely equivalent to 1 over square root of 2, but I'm using it to make your life easier, I promise you. That means that since y is square root of 2 over 2, everywhere there's a y here, that value is square root of 2 over 2. And it is square root of 2 over 2 where the hypotenuse is 1. Here in the unit circle, the hypotenuse or the radius has to be 1, which means this ratio of this side or that side is square root of 2 over 2. That side is square root of 2 over 2 as well. Therefore, when you're looking for the coordinate on the unit circle at 45 degrees, you're going to look at it and go, well, there's x, there's y, it is square root of 2 over 2, square root of 2 over 2.
Wait, how did you get square root of 2 over 2?
From 1 over square root of 2,
Yeah.
did you see where I got here?
No.
No? Okay, I'll roll it back. It's okay, it's okay. On the original triangle, right? On the original special triangle, it's y square root of 2y. Those are the ratios that occur there, okay? Now we need to fit this so this radius is 1. Because on our unit circle, the radius is 1. So I'm going to set this side square root of 2y equal to that 1 and solve for y. So when I set this side equal to 1 and solve for y, to solve for y there, I divide by square root of 2. 1 divided by square root of 2 is 1 over square root of 2. And what I did for the mnemonic device, we'll see in a minute, is I rationalized that. The way we rationalize is multiply by the denominator over the denominator, square root of 2 over square root of 2. When I did that, and understand what makes it legal, Joey, is that's 1 right there. So I'm just changing the not value, just appearance. Tops is square root of 2, bottom square root of 2 times square root of 2 square root of 4, which is 2. That's where I came up with the square root of 2 over 2 for y. And that's the y by itself being square root of 2 over 2. Now here, that means that this side, if that side's 1, must be square root of 2 over 2, and this side as well must be square root of 2 over 2 for that to work if the radius is 1, defining each one of those sides over there.
How did 4 turn into a 2?
Huh?
How did 4 turn?
Because it was square root of 4, Olivia, and square root of 4 is 2. Good question. Good. Ask these questions. Don't get stuck and look at me confused. Ask these questions. It's fine. I can fix it as we go. Are we okay? You all right? So right here, let's talk. This is 45 degrees, right? Don't touch the calculator. What do you think the side of 45 degrees is? Hello?
Square root of 2 over 2.
Check your calculator. I'll bet you it says like 0.707 or something like that. That's because square root of 2 is 1.41 and change, okay? So it absolutely provides the same thing on there. Try cosine. Hello? Cosine of 45? Hello? Now, don't yell this one out. Think for just a second. How about tangent? Don't say it. Don't touch the calculator, you big wusses. If tangent is y over x, what is y over x in this situation? Go ahead. It's 1. Check your calculator now. Tangent of 45 degrees is absolutely 1. And it works as it rolls. And you do any of them. You do any of them. Roll it around, okay? It's kind of a little trick on how it works. I'll do one more. You still okay?
Yeah.
How about cotangent? Still 1, yeah. Because it's not y over x, it's x over y, but they're the same thing. So it's still going to be 1 on that point. And you can define anything as you roll around. That's 45 degrees right there. I'm leaving that, moving on to 60 if you're okay. Are you okay right now?
Yes.
You all right? Make sure you are. Everybody all right? Roll. Now the beauty of the 60 is if you look at it, it is the 30. It's the same triangle. You just turn it. Is all that happens on it. If we're looking is not perfect, by the way, at all. Not to scale. I'll go home and be like, I couldn't do it because it wasn't really 60 degrees on there. I'm explaining it's not to scale. Just doing my best here. This is the 60-degree triangle in this case. This is the 30-degree angle. That's the right angle occurring at the top. If you remember on my 30, 60, 90 at the top, whenever we did this process, whenever we got this side and made this side 1, that was 1/2, and that was square root of 3 over 2. When we did that process, all I'm going to do is going to take this triangle and turn it. This is what's going to happen. Because it's the same triangle. It's got a 30, 60, and a 90. It's got a 30, 60, and a 90. It's just not oriented the same way. So let's orient it the same way. We're going to take, there's the 60, there's the 30, there's the 90. Most of you can see it, but if you can't, hypotenuse is 1. On this one it has to be, it's the unit circle. That's 1. The side in between the 30 and the 90 was the square root of 3 over 2x. The side in between the 90 and the 60 was the 1/2. And therefore, taking the exact same triangle as I had before, but flipping it, now this 60-degree triangle has a height or a y-coordinate of square root of 3 over 2 and a length or a x-coordinate of 1/2. Therefore, its coordinate on the unit circle now, xy, is 1/2 square root of 3 over 2. And we'll get to the mnemonic device in just a second, but you gotta buy it every time. Every time you gotta buy it. You can't just look at me and go, okay. You gotta buy what's happening every time. Without the calculator, no touchies. Cosine of 60. I'm ready when you are. Hello? Check your calculator. Does cosine of 60 give you 0.5? Absolutely it does. It's that point right there. Let's do a tangent. Tangent's fun on this one. Calculator won't help you a whole lot on this, so just give you the decimal. Decimal's going to be no good. Tangent's a measure of y over x on the unit circle. So if you took y and divided it by x on the unit circle,
Square root of 3.
the 2's cancel. Gives you square root of 3 over 1, or just square root of 3. The calculator probably says like 1.79, I think is what square root of 3 is. Whenever you do it. I will not take that on a test or a quiz so that you are aware. I want the square root of 3 piece because I want to know that you get it rather than just plugging it in. It'll be huge on where we go. Let's do one more. Let's do, you know what's fun on this one? It is. We haven't done it yet, okay? Let's do cosecant. Shh. Riley, what do you think?
2 over square root of 3.
He's excited. It's 2 over square root of 3. You're absolutely right, it is, okay? You can look at it 2 ways. You can look at cosecant as 1 over y at this point in time, which is 1 over square root of 3 over 2. When we divide by fractions, we multiply by the reciprocal. The other piece you can understand to it, you can understand at that point in time, is that it's essentially going to be the reciprocal. We know sine is the reciprocal of cosecant. So cosecant is the reciprocal of sine. Sine there is the square root of 3 over 2. Its reciprocal is 2 over square root of 3. Simple on how it works. It rolls around. Everybody still okay? What's happening? One last piece till I give you the dividing device. What's the coordinate here? At 90 degrees. Radius is 1 in this situation, okay? So if the radius is 1 in this situation, what is the coordinate that occurs right there? Hello?
0,
1, 0 or 0, 1?
0, 1.
Now let's do one of them. Let's do a tangent. Tangent of 90 degrees. Not 1. It's x over y, which is 1 over 0, which is an undefined value. At that point.
I just got confused.
Did I flip it?
Yeah, isn't it y over x?
You said x over y, but it's
Oh, I wrote it.
You wrote it right. You just said
I said it wrong. My fault. Sorry.
Okay.
Tangent's y over x. Y over x is 1 over 0, which is undefined. Yeah? My fault.
That's what I said.
It's okay. I say lots of stuff, and I mix a little bit up. My apologies. So here's the deal, and here's why I like unit circle. Is I need you to understand these principal coordinates to be able to do all of it. That's all I need, okay? And let's be honest. That should be given, that should be given, this should be given, and this should be given. Those should be obvious points around it. What I really need you to know, that. Those three. When I did this, I started out doing it with special triangles. This was back whenever I was in school. And then I looked at it and saw this little relationship happen in between them. And thought, that just seems easier. Your call. You let me know. I don't care. Okay? Just make sure you know how to do it. As you're looking at the principal values up here, all the numbers I'm using in these cases, it's a combination of 3 numbers. Every one of them has a denominator of 2. Every one of those numbers has a denominator of 2, right? And it goes in sequence, square root of 3, square root of 2, square root of 1. Now you don't see the square root of 1 up there, but what is square root of 1?
1.
That's why it's a half up there, okay? That was easy for me to memorize. It really was. 3, 2, 1, all the square roots, denominator 2. Rolls. So I did that to start it, and then I used some logic beyond there. I knew those 3 principal coordinates, and I looked and I said this. Hey you, what's in the middle of those 3s? Of those 3, which one of those is in the middle? Which is in the middle? 30, 45, or 60?
45.
That's why it gets the square root of 2 over 2's with it, because it's in the middle, right there. And more specifically, it has to be the same thing, square root of 2 over 2, square root of 2 over 2, because at a 45-degree angle, the x and the y have to be the same. Because the projection angle, the 45 and the 45 on either one are the same. Therefore, their sides are going to be the same. That's why it maps to the same. But I just simply looked at it and said, all right, I know this one's in the middle. And once this one's in the middle, I use that. We don't use them anywhere other than 45. It's the only place it's used, okay? So I used that, knew it was there. Cool, done. If you look at these two, they're just flips of one another, okay? You take x and y and flip them, you get up there, on that coordinate up there. This one was a little tougher for me to get. Well, I started looking at it and going and messing it up, like, because I couldn't figure out if this was 1/2 square root of 3 over 2 or if that was, and I kept on mixing them up. And the way that helped me may help you. What's bigger? Square root of 3 or square root of 1? Good, last hour they messed that up. I feel better for you. We can agree that this is a larger value, correct?
Yeah.
That's a little smaller? When you look at 30 degrees, and I would diagram this out in my head. What's bigger at 30 degrees, x or y? X has to be. So x has to be the bigger value of the square root of 3. Y has to be the smaller, or the 1/2. I don't know if it works for you. That's what I did to make it work in my mind. And then anytime I did the 60, I'd look at the 60 and I'd kind of diagram it out in my head and go, all right, what's bigger here? Well, y is a lot bigger than x is. I'm not using the square root of 2 over 2. It's not in the middle. It's one of those two. You're bigger than you are, so you must be x. You must be y. Or excuse me, you must be y. You must be x. Excuse me. As it went through. So I used that bigger-smaller relationship to make it work, to map it throughout. Again, up to you. I don't care. I just think the mnemonic device of 3, 2, 1 with square roots over the top of them and middles and sides can help. It's up to you on how that works. Questions that you have right now? Hello? Did you get what I was saying? Are you all right? Are you still alive? The good news here, the really good news here, I told you that all you had to have was this. Because based upon reference angles, if you know this and you know how to map it to the other quadrants, you can figure out anything else you want. Anything else you want. Here's how it works. Going into the second quadrant, oh, by the way, hey you, face, here's, what's positive over here, x or y? That's why every one of them was positive. As we come over here, the only difference is they're both not positive. Second quadrant, got it right? What's positive over here, x or y? So it's like negative comma positive. You talk about the coordinates over there. The x is negative and the y is positive in that particular quadrant. Anytime you find a reference angle that is equivalent to the reference angles over here, you can map it and then use the same coordinates. What the heck did he just say? The 30-degree reference angle over here is what? Remember, this is 30 degrees. That's the reference angle, so what's this angle right there? Hello? 150.
Oh, yeah.
So for the 150-degree angle, the one with the 30-degree reference angle, all I have to know, that's the 30-degree one. So the 30-degree reference angle here is the same. The only difference between the two,
This is negative on that.
x is negative
Oh,
on it, because it's in that second quadrant right there.
oh,
And it works. It absolutely works. Check it out. Plug in one of them. I don't care. Plug in cosine of 150 degrees. It'll give you the equivalency of negative square root of 3 over 2. It gives you the exact same thing. And that's what I was talking about, is by knowing these, you can map anywhere around the entire thing to make it work. They ask you about 135 degrees. Okay? I say what I say. I say sine, whatever. Of 130 is what I'm going to do. Sine of 135 degrees. You need to look here and go, all right, 135 degrees, right? 135 degrees is what is a reference angle right there? Hello? 45. So that's a 45-degree reference angle. My 45-degree coordinate is square root of 2 over 2, square root of 2 over 2. However, in the second quadrant, that indicates that the x has to be negative for that to work on that one. And then I do whatever I need to from there. Sine is y, y is square root of 2 over 2. I'm done. But it maps into every quadrant if you understand reference angles. It applies through. It allows you to roll around the unit circle at any individual coordinate. That's why I said if you know that, and that, in a spatial understanding, you can have everything the whole way around. Are you still alive on what's happening right now? Cool. This last coordinate up here, the 60-degree reference angle is 120 degrees. At 120 degrees, it is the same exact coordinate as it is at the 60-degree reference angle. Just make your x-coordinate negative. Therefore, we are at negative 1/2 square root of 3 over 2. That's exactly what's happening right there. Still alive and okay? At least I got one. I'm going to roll down here and take care of this third one. You're going to take care of the fourth one on your own. Is what's going to happen down here, okay? So let's go to the third one and make sure we know what the heck's going on, and then we'll bounce it around to the fourth quadrant. As you look at the third quadrant, draw on your own paper, not hers. As you go to the third quadrant over here, what's negative, guys? X or Y?
Both.
Well, then mark. Therefore, since you know both of them are negative, you're going to copy the exact same coordinates on there. You're just going to make a double negative action happen. All right, so we're at the 30-degree reference angle. The 30-degree reference angle is 180 plus 30, which is 210. And at 210, it's the same as the 30-degree reference angle. Just make them both negative.
For the,
Yeah.
I don't know, this line going right here, is it 0, 1?
180?
Yeah.
Good call. Hey, you, I forgot to define it. Good call. What's this point? That's 1, right?
Negative 1, 0.
It's negative 1, 0. My fault, Olivia. That's 180. You're right. Forgot to give you that. Other.
Wait, how did you know that the 210 was the 30-degree over here?
Because I looked at it, I said, I know reference angle is the angle in between this and the x-axis. If that's 180, that's got to be 210. Good
Okay.
question. Continuing. 45s. A 45-degree reference angle into this quadrant is 180 plus 45, which is 225. And when you deal with 225 degrees, it is the exact same as the as the point on 45. Just make it double negative. Finally, we've got the last one. The last one is a 60-degree reference angle in the third quadrant, which is 180 plus 60, or 240. The 240-degree angle, let's move this over just a little bit so that they can see it on the video. Negative square root 2 over 2, negative square root 2 over 2. The 240-degree angle right there is the same as the 60, which is 1/2 root 3 over 2. You're just going to make them both negative. Let's make that work. 270 straight bottom. At 270 degrees, we're at 0, negative 1. Oh man, I got it messy in there. take charge on this side. You guys should be qualified to take care of the rest of it. I'm gonna clean this up here, because that's a little messy.
Hey Spinks, this is about to die. Do you have any like
We're
parting
good.
words of wisdom? No.
Make sure you can take care of this water and understand it. Thank you for your time. Good.